I'm Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about the problem solving on IP socket options and ICMP socket options. Here is problem solving on IP socket options and ICMP socket options. What are the problems? So how we can solve the problems. First, now if you take the internet protocol socket, the options, IP socket options. The problem is setting the time to live value. That means the issue is you need to control the maximum number of hubs or routers to packet can process through the network. Here is maximum number of the hubs. Now we have to control the maximum number of hubs. Why? Because now we can allocate the time for each and every hub for transmitting the other data. Here is the solution is int TTL64 example TTL value, that is set socket the option function socket file descriptor IP protocol IP TTL. So TTL time to live, isn't it? Time to live and at the rate of TTL and size of the TTL. So TTL value. So with this now we are setting the time for each and every routers for packet transferring one network to another network. Whatever the packets now we are going to transferring, so that the packet transparency time can be set. Based on the time we have to transfer the packets from one network device to the another network device. If the time is out here, the packets can be removed, the packets can be made into the drop stage. Here this sets the TTL value for outgoing packets. Whatever the outgoing packets is there, now which is setting the TTL value. Limiting the number of hubs they can take. It is limiting the number of hubs and it can be the take. This can be very useful in limiting the packet life, the spam, and controlling the network routing behavior. Here, next the problem in IP socket option is a IP header inclusion. Enabling IP header inclusion. By enabling the IP header inclusion, what other problems will be arise for certain applications? Now, raw sockets. Example is a raw socket application. So you need to include the IP header in the data sent through the socket. So this is the one issue. So that is the solution is a int opt optional value is a 1 and set socket optional value, that is a socket FD IP proto underscore IP and IP header INCL inclusion. That means IP header inclusion optional value size of the optional value. With help of this the function now IP header inclusion to 1. So which ensures that the applications provides the IP header. So this is essential when working with the raw sockets at client side and server side, where custom headers are required. Here this is the solution for that one. So with help of this the function now we are enabling the IP header inclusions. Next setting the type of services, that is a TOS. So at the IP socket options now, how we are going to setting the type of services. Generally here the issue will arise. You need to prioritize the packet based on their type of services. Packet based on their type of services. Example, minimizing the delay and maximizing the throughput. So that is the solution is IPTOS, IP2 yes low delay. For low delay, setting the socket option, socket FD IP proto IP IP TOS. So that is a size of the TOS. Here it, which is these are the function. These are the function now. What it is doing, adjusting the type of service field, which is allow you to hint the desired the quality of the services, which is influencing the routing decisions and handling by the routers. Multicasting with the IP sockets. Generally, it is another issue. Multicasting. So sending or receiving the multicast the packets. So multiple other packets now if you want to send or if you want to receive from the client the devices. So some multicasting the problem will be arise with help of the IP socket specific the socket the configuration. This is a problem. Now the for that one solution is a joining a multicast group. With help of this multicast at the group now we can resolve that as a problem. That is a struct IP M message request MREQ. MREQ. So multi MREQ, which is a multicast the request. MREQ dot IMRE multicast address. Multi address at socket side, that is dot socket underscore ADDR. INET AD underscore ADDR. So the multicast, the IP address is 239.0.0.1. The multicast, the group address. So it is the multicast, the group address, that is MREQ.IMR interface dot S underscore ADDR. So that is H2N. H2N. So which is INADDR underscore NE. Use the default interface. Default interface. Set socket option. Set socket option. So socket FD file descriptor IP proto IP underscore ADDR. So membership M request size of the M request. With help of this now the multicasting can be done leaving the multicasting group. The for that one the function is set socket socket FD IP proto IP drop membership request multicast request particular the address and size of the multicast. So these are the functions which allowing the applications to join or leaving the multicast group in a communication. So with these the multicast the communication here. Now we can establish the communication from multiple devices. The server now, the server mission, so which is receiving the information from the multiple client devices. Here is multiple other client the devices now. Generally, we can receive the information. So it's a client 1, client 2, and client N. Client N up dash client N. Multiple the devices now, which is enabling the communication with multicast technology efficiently. Now we can able to receive the data from multiple other clients with help of the multicast technologies. Handling fragmentation is the problem. You want to control whether the packets are the fragmented or require the notifications if the fragmentation is occurred. That means here the solution is int don't frag is equals to 1. Here set socket option socket FD IP proto IP MTU discover. So ampersand of the don't frag size of the don't frag. With help of this the function now we can with help of this the function now at the IP socket we can handle the fragmentations. Here ICMP Internet Control Message Protocol. ICMP is nothing but a Internet Control Message Protocol socket option. So here is the problem is creating and sending the ICMP echo request. So this is the problem. Here the issue, you need to send ICMP echo request, Internet Control Message Protocol request, commonly used with the ping utilities to check the network connectivities. Here is the solution is the code is struct ICMP header ICMP header dot ICMP type of the protocol. Which type of the protocol now we are utilizing? That is a ICMP echo message. ICMP echo means same message can be responded. Whatever the message you are sending from the client, so the server is responded to the responded to client the same message. That is ICMP header ICMP code is equals to 0. ICMP the header. So ICMP checksum which is 0. Initially 0 before checksum the calculations. ICMP header, that is ICMP the checksum, calculate the checksum value at ICMP header, the size of the ICMP buffer. Send to socket FD and ICMP the address size of the ICMP is 0. Struck socket address at the destination address, the size of the destination address. So this is the other code for the socket options. So this allow you to create and send the ICMP echo request now, typically used to determine if a host is reachable and measure the round trip time. Next, the problem is receiving the ICMP echo request. You need to handle the ICMP echo request. Echo replies. Now, this is a problem which responses the ping requests to determine if the target host is alive. So this is the issue. For that one is the code number. For that one is the code is here. Now the socket structure socket that echo the socket now we are declaring here. The size of the buffer now we are giving. The port number of the particular the buffer. Here is the 1024 is the buffer the size here. Receiving from data is receiving from socket FD buffer, size of the buffer here. So this is a code for receiving the data from the clients, and after receiving now ICMP the protocol can be utilized that can be handle the address, the structure of the ICMP which is address to particular the buffer with help of this IP address and header length. That means skip the IP header. If it is if the condition is a true, ICMP header greater than the ICMP, the type of the ICMP, so ICMP the echo replay. If it is true, echo replay is a true now. Handle the echo replays. So that approach now which allow to capturing and processing the ICMP echo replies, so enabling the functions like network monitoring and diagnostics. Next, the problem is handling ICMP destination unreachable messages. Here, unreachable are the messages. When sending data, you need to handle the cases where the destination is unreachable. The code is buffer size is 1024 and receiving the data from the buffer. Here is the structure type. ICMP header is a structure type. Struct ICMP buffer IP header length. If ICMP header is greater than ICMP type, that is a ICMP destination unreachable. Which handle the destination is unreachable. And which receiving and analyzing the ICMP destination which is unreachable messages. Unreachable messages. So let us do the application here. So which is the detected and responses to the routing issues on unreachable host. The problem is detecting ICMP redirected messages. That means here the issue is the application to need to adjust its routing based on the ICMP redirect messages. For that, the code is receiving the messages from the buffer, the size depends upon the buffer size. Now we are setting the structure by using the, you have to assign the ICMP buffer and length of the IP address to the ICMP header. It will be pointed. It will be pointer type. ICMP header is a pointer type. If ICMP header is greater than the ICMP redirect, now which is handle the ICMP redirect, adjusting the routing table and configurations. It will be configured as needed. If it is needed, that will be the configured. The handling the ICMP time exceeded messages. If the time is exceeded, message receiving message is time is exceeded, so that can be handled time to live. You want to detect when the packets are dropped due to the exceeding time. It will be the handled with help of this the code. Now, if it is the if this the function is a true ICMP header, if it is a greater than the ICMP type, ICMP time exceeded. If it is a true here, now which is handle the time exceeded, that is time will be exceeded due to the drop out the packets or any damages, packet is damages while transmitting the packets between the two hosts. That means one network to another other networks. So trace the routing applications. Here, this is the useful, very useful for the applications like trace route, where you need to identify the points at which the packets are dropped. These are the solution addresses the common issues which is encountered when working with the IP and ICMP sockets options, which is offering the ways to manage network and communications, diagnostics, and error handling effectively. Here, real-time problem is overloaded server during the peak traffic in a real-time application. For that one here, the solution is auto scaling can be done. Auto scaling can be done here. So on a cloud platform, it will be implemented on a cloud other platform to automatically add or server when traffic increases, reduces during the peak time of the transmission. Load balancing, with load balancing, incoming traffic across the multiple servers to prevent any single server from the becoming bottleneck. Content delivery networks. Content delivery networks now, which is uses the distributed content closure to user, which is reducing the load on a original servers, improving the response time. Here is the network congestions in a real time. So network the congestions in a real time here generally that can be resolved with the traffic shaping. Implementing the traffic shaping policies now, the congestions control can be overcome. Flow of outgoing data can be controlled, and so the burst the traffic can be controlled with help of the traffic shaping. Priority queuing also we can control the congestion. That means ensuring that real-time traffic is transmitted at the less critical data. Congestion avoidance algorithm, by using this congestion avoidance algorithm, we can control the congestions. Ensuring low latency in a real time. So it is a issues or direct market access now. We can ensure low latency in a real time financial trading system, which is minimizing the number of intermediaries between the trade and market and reducing latencies. So trading and approximating the hosting, that is close as a application to exchanging the data center to reduce the time taken for a data to travels, and optimizing the network, that means use the dedicated high speed network other connections, improving the performance for the high speed network other connections, and the specificity also improved, and minimizing the use of network protocols, so that introduce the unnecessary overheads like certain encryption protocols that can be added the latencies. Textbook for this the topic is TCP/IP socket in a practical guide for the programmers. So this is the textbook for this one, and this is a reference book, Linux programming interface, Linux and Unix system programming handbook. So this is about the IP socket, the options, and the ICMP socket options. Whatever the problems are issued, that can be resolved. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.